Hey guys! So today we're going to start a new lesson called Ionic Bonding and Ionic Compounds. As you guys remember from lesson 6.1 when we were comparing covalent and ionic bonds, in a covalent bond, electrons are shared between atoms. In an ionic bond, however, electrons are given from one atom to another, right? Which causes them to stick together. This happens usually between a metal and a non-metal. They have extremely different electronegativities, so instead of sharing an electron, one of them will completely give it up and give it to the other one. So as you can see here in sodium, if you look at its valence shell, it has one electron on its valence shell. If it just loses this one electron, it'll be nice and happy and stable because it'll have 8 electrons on its valence shell, which is a state that all atoms want to be in. And if you look at chlorine here, he has 7 electrons on his valence shell. And as you know, almost all atoms that we're going to talk about in this lesson, or in this class because it's grade 10, have 8 electrons on their valence shell. But you see, chlorine has 7, so he's missing just 1. So the easiest thing you can think of doing is that sodium will give his 1 electron to chlorine, and when this happens, sodium now has a full 8 electron valence shell, and so does chlorine. Now, when sodium loses an electron, even though he's happy and stable, he gained a positive charge because he lost an electron. And when chlorine gained this electron to become nice and happy and stable and have a full valence shell, he gained a negative charge because of that extra electron. So when you have something positive and something negative, opposites attract, so they come together. And this is basically how an ionic bond forms. One loses an electron, the other gains. The one that lost becomes positive, the one that gained becomes negative, and the positively charged and the negatively charged atoms bond to each other through electrostatic forces. All right, so if you're going to compare structures of ionic compounds and covalent compounds, you are going to see something very, very different. So when you go to an ionic compound, you won't see an individual set of atoms stuck together. So for example, maybe this is the chlorine and this is the sodium. You're not going to find them alone. You're going to find them bound to all kinds of other sodiums and chlorines. That's because they are charged, right? So if this one's negative, he's going to bind to all of these other positive sodiums, and all the positive sodiums are going to bind to all kinds of negative chlorines until they form a huge structure like this. While if you look at a covalent bond, you're going to find an isolated structure. So this is an example of a water molecule. Right here, this is a bond. This is where the electrons are being shared, and 2 hydrogens are stuck to 1 oxygen. This does not change. It stays like this all the time, and it doesn't randomly start binding to other elements or other compounds. So you can see the difference. Ionic compounds are large and bulky and are made up of many, many, many units of the same atoms, while covalent compounds are made up of 1 unit of atoms. Okay, so ionic compounds usually make up a crystalline solid that looks like this. All right. Now, when you look at an ionic compound, remember that the charges need to be balanced. I can't have 16 chlorines and 1 sodium. For every 1 chlorine in the compound, there has to be 1 sodium. That's why it's called sodium chloride, because the ratio of sodiums to chlorines is 1 to 1. NaCl, not NaCl2 or anything like that. The formula unit is the simplest collection of atoms from which an ionic compound formula can be established, which basically means that the charges have to be balanced. If I have 1 sodium, I have to have 1 chlorine to balance out the charge. For every positive, I have to have a negative so that they can cancel out and become overall neutral. And remember, in covalent compounds, atoms are not charged. In ionic compounds, atoms are charged. All right, so we're going to talk about how we can draw ionic compounds and ionic reactions using Lewis structures. As you guys know, in ionic reactions or in ionic compounds, an electron is moved from one atom to another. They're not being shared in the end. So you're going to end up getting something like this: two charged atoms at the end and two Lewis structures at the beginning. So we're going to use this periodic table again. You guys know that group 1 has 1 valence electron, group 2 has 2, 3, 4, 5, 6, 7, 8, right? And in general, in ionic compounds, we're going to be dealing with one element from this side of the periodic table, and the other element is most likely going to come from this area of the periodic table. So a metal and a non-metal. So let's do this. The first thing we're going to do is we're going to find the Lewis structures of each of our elements. So the question here asks, use electron dot notation to demonstrate the formation of ionic compounds involving calcium and oxygen. So I'm going to go back here. I'm going to find calcium. Calcium has 2 valence electrons. So I'm going to draw it like this. 1, 2. And then I'm going to go find oxygen. Oxygen right here has 6 valence electrons. 1, 2, 3, 4, 5, and 6. So if I look at these, I know that calcium needs to lose 2 electrons to be happy, and oxygen needs to gain 2 electrons to be happy. So I'm going to figure out what my final charges of my elements should be. Calcium needs to lose 2 electrons, so calcium should be +2, and oxygen needs to gain 2 electrons to gain a full octet, right? So oxygen should be -2. So I want to check to see if these charges are balanced before I go any further. +2 and -2 equals 0. As long as your answer is equal to 0, then you can proceed with the actual reaction. So now I'm going to draw all of this together. Oops. Calcium with my dots, don't forget to draw the electrons, plus oxygen, 1, 2, 3, 4, 5, 6, gives you calcium +2 plus oxygen -2. The oxygen has 8 valence electrons. So the charges here are balanced, and this is my overall answer. Okay, so let's try another example. Here we're going to be talking about magnesium and chlorine. First thing I want to do is I want to go back to the periodic table and find magnesium. Magnesium is in group 2, so it has 2 valence electrons. Chlorine is right here. It's a halogen, so it has 7 valence electrons. So I'm going to go here. We're going to draw that. Magnesium, 1, 2, and chlorine, 1, 2, 3, 4, 5, 6, and 7. Now, I can see here that chlorine is missing 1 electron, which means that in the end, it needs to gain an electron and become -1. Chlorine's overall charge needs to end up being -1. Magnesium needs to lose 2 electrons, so it's going to become +2. Remember, for every electron you gain, you become negative. For every electron you lose, you become positive. So magnesium needs to be +2. Let's check our overall charge. As you can see here, +2 minus 1 equals to +1, which means that we're still missing something. So what you can do here is possibly add another chlorine into the equation. So we can make it like this. magnesium with 1 electron. You know what? I will draw it up here. Magnesium has 2 electrons, and I have a chlorine here that's missing 1, and a chlorine here that's missing another electron. See this little blank space? So one of these electrons can go here, and the other electron can go here. So overall, I'm going to get magnesium plus chlorine plus another chlorine gives you magnesium plus 2 plus Cl minus plus Cl minus. Remember that if we have a charge of 1, we don't always have to write the number 1. We can just put a negative or a positive. So this right here is my overall reaction. You have everything at the beginning, all your Lewis structures, and then you have your charged particles at the end. All right, so now you guys can go and do the worksheet on Shobi and then do the quiz. Good luck.